Right now, try to remember the exact moment you fell asleep last night. Not the moment you got into bed, the actual transition, the second you went from awake to gone. You can't do it. Nobody can, and it's not because your memory is bad. It's because your brain is built to erase that specific moment on purpose every single night for your entire life. By the end of this, falling asleep is going to feel a lot less like drifting off and a lot more like getting switched off by something else entirely. Here's the version most people believe. Sleep is a gradual fade. You get tired, your eyes get heavy, and you sort of ease downward into unconsciousness like a dimmer switch turning slowly to zero. It's a nice image, it's also wrong. The actual transition is closer to a trapdoor than a dimmer, fast, abrupt, and over, before you'd have any chance to narrate it to yourself. Researchers who study this call it sleep onset, and depending on how you measure it, the whole thing can happen in under a minute. Not a slow fade, a drop. There's actually a way scientists test this. They'll have someone hold a small object loosely in one hand while lying down, wired up to monitors, and just wait. The moment the brain crosses into early sleep, the hand relaxes. The object drops, and the noise of it hitting the floor sometimes, not always, yanks the person right back to the surface. Confused, with zero memory of having gone anywhere. They'll insist they were never asleep. The machine disagrees. The machine is right. That gap between I was definitely still awake and what the data actually shows is basically the entire mystery this video is about. So why does it feel slow from the outside? Mostly because you're remembering the minutes before. The heavy eyelids, the yawning, the third time you reread the same sentence in a book and gave up. That part you do remember because that part is still you, awake, recording. The actual switch flip is the part that vanishes, and it vanishes because of where it happens in the brain. Here's where it gets genuinely strange. Your hippocampus, the part of your brain responsible for laying down new memories, doesn't stay online right up until the lights go out. It starts powering down before full unconsciousness hits. So there's a window, a real one, where you're still technically experiencing things. Sounds, sensations, stray thoughts, but nothing is being filed away. No tape is rolling. It's not that you forget the moment later, it's that the moment was never recorded in the first place. Which is a very different, and frankly creepier, kind of forgetting. Think about how rare that is anywhere else in life. You don't have a similar blackout for, say, brushing your teeth or walking into a room or eating a sandwich. Those moments might be boring, but they get recorded. You could remember them under hypnosis or with enough effort, even if you don't normally try to access them. Sleep onset doesn't work that way. It's not buried. It's not repressed. The footage genuinely doesn't exist. Now, you'd think evolution would consider this a bug. Out of all the moments to lose, you'd want to remember the one where you went from alert and capable of running from something to completely defenseless on the ground. That seems like exactly the moment your brain should be paying the most attention, not the least. So why build it this way? The honest answer is that memory and vigilance are two different jobs, running on two different systems, and during the transition into sleep, your brain appears to prioritize one over the other. The system watching for threats, things like sudden noises, temperature changes, a shift in the air, actually stays semi-active for a while longer, which is why a loud sound can still snap you back awake in those first few minutes. But the system writing things down for later, that one checks out early. You're still being monitored, you're just not being archived. There's a kind of brutal efficiency to that when you think about it. Memory is expensive. It takes energy and tissue and time to consolidate, and your brain is apparently willing to spend almost none of that budget on the exact window where you're at your most vulnerable and least useful to remember anything about. It's not sentimental about it at all. It just shuts the recorder off and gets on with the business of keeping you alive, which, when you say it like that, is either deeply reassuring or deeply unsettling depending on how you're feeling about your own brain today. Here's the part nobody talks about, though some people do get flickers. They're called hypnagogic experiences, and they sit right in that gap between waking thought and actual sleep, falling fragments of conversation. A flash of an image that doesn't belong to anything. The sensation of falling, or your whole body suddenly twitching like you missed a step that wasn't there. A hypnic jerk, technically, and yes, that's a real term, and no, it does not mean anything is wrong with you. These flashes are some of the only surviving footage from that no recording zone, and they're famously unreliable, fragmented, and almost impossible to hold on to once you're fully awake. And once you're actually under, the editing doesn't stop. It just changes departments. You'll spend roughly 2 hours a night dreaming, every night, whether you remember a single frame of it or not. Most of that gets deleted too, not because dreams are unimportant, but because the same memory recording system that clocked out at sleep onset stays mostly offline for most of the night. The dreams you do remember are almost always the ones you happened to wake up during or right after, which means your memorable dreams aren't actually the memorable ones. They're just the ones that got lucky with timing. Somewhere out there is the best dream you've ever had, and you will never know it existed. This is also why dream recall feels like trying to hold water in your hands. You wake up certain you'll remember it. The plot was vivid, there was a whole storyline. Maybe your childhood house was involved for no reason. And by the time you've brushed your teeth, it's mostly gone, leaving behind one random detail like a doorknob, with no explanation for why that's the part that survived. Dream memory and waking memory just don't run on the same rules, and trying to apply normal memory logic to a dream is a little like trying to use a parking ticket to board an airplane. Wrong system, wrong department, no refunds. This isn't a comfortable answer for anyone who wants a simple, tidy story about how the mind works. Sleep researchers still argue about exactly when awareness ends versus when memory ends, and whether those are really two separate switches or one blurry one. Some studies put the actual transition window at under a minute, others suggest it's messier and varies wildly by person, by night, by how tired you actually are when you lie down. Nobody's claiming to have this fully mapped. What they do agree on is the basic shape of it. There's a real, measurable gap between when you stop encoding the world and when you actually go fully under, and that gap is yours every night, and you will never get to see inside it. It's also worth asking whether every brain handles this gap the same way, and the honest answer is not even close. Babies, for one, don't fall asleep the way adults do at all. They spend a much larger chunk of their sleep in lighter, twitchier, more dream-heavy states, which is part of why a sleeping infant looks like they're having an argument with someone, eyebrows going, mouth working, fists clenching, all while completely unconscious. Nobody knows for certain why babies need so much more of this twitchy, half-aware sleep. Though one leading idea is that it's basically construction work. The brain wiring itself up in real time, with all that flickering activity being less rest and more renovation happening while the building is technically still occupied. Animals make the picture even stranger. Dolphins and some whales never fully lose consciousness at all. They sleep one half of their brain at a time, one eye open, circling slowly, so they don't drown or get picked off mid-nap. Birds can do something similar, catching seconds of single hemisphere sleep mid-flight, which is the closest thing nature has to napping at your desk without your boss noticing. Humans don't get that option. We go all the way under both hemispheres completely, which is exactly why our ancestors needed a group of other people nearby who weren't asleep at the same time. Sleep, for us, has never really been a solo activity, no matter how private it feels lying there in the dark. And honestly, there's something almost funny about how unbothered we are by this. People will spiral for hours over forgetting where they put their keys. Nobody loses a single night's sleep, pun fully intended, over the fact that they have a guaranteed scheduled memory blackout built directly into their biology every 24 hours, no exceptions, no opt-out. We've just decided that's normal. It is normal. It's also, if you actually sit with it, one of the strangest things your own body does to you without asking permission. So tonight, it'll happen again. You'll be lying there, maybe scrolling, maybe thinking about tomorrow, maybe rereading that same sentence for the third time. And at some point, without any kind of warning or farewell, the part of you that watches and remembers is going to clock out early and leave the rest of the show unrecorded. Somewhere in the hours after that, you'll dream things you'll never know you dreamed. You won't notice any of it happening. You never have. Somewhere in that handoff between the brain that experiences and the brain that keeps the receipts, there's a few hours of your life that exist for absolutely no one. Not even you.